We've made it to the end of the Chapter 4 lecture guide. The last problem is a titration calculation. So we know that a titration is just a laboratory method of mixing two solutions with the goal of finding the equivalence point. The equivalence point is just the point where we've hit the stoichiometric molar ratios from the balanced equation. So you'll notice some vocabulary, like sometimes they'll say like at the end point or the equivalence point. And so now I just need to know that, oh, no big deal, that just means that we're at the stoichiometric mole ratio from the balanced equation. We might see this word neutralize if it's an acid-base titration. And again, that just means that we've got equal moles of acid and base, so that my products are just some kind of a salt, an ionic compound, and water. Here's a pretty typical calculation involving a titration. How many milliliters of a 0.1 molar hydrochloric acid solution are required to neutralize 25 milliliters of a 0.2 molar sodium hydroxide solution? So first thing, when we're mixing any kind of solutions and looking at some stoichiometry, I need a balanced equation. So let's see, we've got our HCl hydrochloric acid reacting with sodium hydroxide. Super typical neutralization. And so after a while we might just know that this is a 1-to-1 mole ratio. My hydrogen is +1, my chlorine is -1, sodium is +1, hydroxide is -1. So it's a double replacement. I'm going to get the sodium with chloride. There's my ionic salt. And hydrogen with hydroxide, also known as water. Again, we can titrate acids and bases, or we can really titrate any solutions. It's just a lab method where I'm looking for that mole ratio in the balanced equation, which means I need a balanced equation. This one happens to be 1-to-1 ratios, which is fantastic. But it doesn't have to be 1-to-1 ratios, which is why step 1 is always to check a balanced equation. Now, step 2, when we mix these acids and bases or whatever our reactant solutions might be, there's got to be one solution that we can use to find moles. So I'm looking for the volume of this 0.1 molar hydrochloric acid solution. I know that I have 25 milliliters of 0.2 molar sodium hydroxide solution. One solution's got to give me enough information to find moles. That is going to be this guy. So we're going to use this one to get moles of sodium hydroxide. It's a 0.2 molar sodium hydroxide solution. And molarity is moles per liter. So I'm going to have to switch that 25 milliliters to 0.025 liters. We cross multiply, right? Cross multiply to find moles. So I'm looking at about 0.00500 moles of sodium hydroxide. One solution's got to give you enough information to find moles. It could also be a solid. Maybe they're using 25 grams of a solid. Well, I could turn that into moles, but I got to be able to get moles, because the whole point of this is that when I neutralize the base being the sodium hydroxide, I've got the perfect stoichiometric ratio from the balanced equation. I've got equal moles of hydroxide and hydrogen, so that all I form is water on the product side. Water and salt, which is neither acid nor base. It's totally neutral. So once you've got moles of one reactant, I'm going to look at the ratio in the balanced equation to get moles of the other. Now, if I wanted to be a perfect rule follower, I would maybe set up something that looks like this. 0.005 moles of sodium hydroxide. And I'm going to do some little mole stoichiometry. Cancel moles of sodium hydroxide. Switch it to moles of the other solution. I'm looking for the amount of HCl needed. going to switch it over to the HCl. This is a fantastic 1-to-1 ratio, so maybe I could even get away with skipping this step. 0.005 moles of HCl. But it's good to just throw it on paper here so I know kind of where I'm going with this. It wouldn't have to be a 1-to-1 ratio. Now, it's probably not going to be anything super crazy. Maybe it's 1-to-2, 1-to-3. And so often I could figure out moles of the other solution just by inspection. Maybe I don't have to write this red step, but I have to start with moles of one reactant and then use the ratio of the balanced equation to get moles of the other. Now I can solve the problem. They want to know how many milliliters of 0.1 molar hydrochloric acid is required. I'm trying to hit the stoichiometric ratio between these two reactants. Then I know that I have neutralized the base. I've got equal moles of hydrogen and hydroxide to really just form water. So I first figured out how many moles of base. Now I know how many moles of acid I need, but we want to measure it by its volume in milliliters. So check this out. I know that I've got 0.1 molar HCl, and molarity equals moles, moles per liter. I have the moles, 0.005 moles per liter. That's what I want to solve for. Check that out. All right, so we're going to cross multiply. I'm going to do a little algebra. Cross multiply and divide so that I get a volume of about 0.0500 liters. Now that's volume of that 0.1 molar, HCl. Now if I wanted to, I could bloop, bloop, bloop. I could flip the decimal spot. Let's get some of this out of the way. I could flip the decimal spot, and that really is, like about 50 milliliters. And there we have it. This is just solution stoichiometry. All the magic happens in here. There's got to be one solution that I can find moles of. Once I know moles of one solution, I can look at the ratio in the balanced equation to get moles of the other. From here, I could do so many things. This is the best spot. In this case, we had moles of hydrochloric acid, and I wanted to figure out volume. Maybe I would have moles of HCl, and I want to turn it into grams. Maybe somebody's measuring a solid, and it says how many grams of HCl. Maybe I know the volume. Maybe they would have said, yeah, you had 50 milliliters. What's the concentration of the HCl? This is where all the good stuff happens. Once I know moles of HCl, I could switch it to a volume, I could switch it to a concentration, I could switch it to a mass by using the ratio from the balanced equation.